Here we have our Turvy problem number 12. This is also related rates. Let's take a look at this problem and see if we can tackle it. A student at James Wood was painting the high school and standing at the top of a 25-foot ladder. She was horrified to discover that the ladder began sliding away from the base of the school at a constant rate of 2 feet per second. At what rate was the top of the ladder carrying her toward the ground when the base of the ladder was 17 feet away from the school? So as you know, we need to draw a picture of this thing, and it's okay to have a little fun with this. I'm going to draw the side of the school here. This is the brick wall. It doesn't really look like a brick wall, but let's just pretend it is. I don't want to spend too much time drawing because I'll just waste your video time here. But that's the school. And then the student is on a ladder. And so the ladder obviously leans up against the wall. Oops, something like this. And then this is the ground down here. We'll pretend this is grass. All right. And you can see this forms a triangle. In fact, it forms a right triangle. So what happens is she freaks out because the ladder starts sliding. The bottom, the bottom of the ladder starts moving away from the building in this direction. And that means, because that ladder is fixed, that the top starts coming down. So this distance is changing, and so is this distance. The ladder itself is 25 feet, and that's constant. Like, the ladder is not changing measurements, so we're going to call that 25 feet. But what is changing is the height from the ground to the top of the ladder. So I'm going to put a variable h over here. And then the other thing that's changing is on the ground here, the distance from the building, the wall, to the tip of the ladder is growing, and that's changing. So I'm going to put a variable here and call that x. Okay, now that I've established my variables, let's get some information down here. The ladder is sliding away from the wall at 2 feet per second. That's a rate, that's a derivative, and that's actually the derivative that goes along with x. So that is dx dt. So I know dx dt is positive 2 feet per second. I know it's positive because it's getting bigger, right? This distance here is getting further away from the wall. It's getting bigger. And we also know that the ladder is 17 feet away from the school at the period of time that we're asking about. So that means x equals 17 at that point. So I'm going to write that down. What we're trying to find out is the rate. It says, at what rate is the top of the ladder carrying her toward the ground? So in other words, we're trying to find out how fast it's going down. That's dH dt. That's what we're trying to find. Then I like to put a question mark on that because I don't know what it is. Okay, so what we're going to do is we're going to write an equation like we always do. From this picture, my variables involve the legs of a right triangle, and we know the hypotenuse, so I'm going to take a guess that this is a Pythagorean Theorem problem, and I'm going to do x squared plus h squared equals, what is that, 625? 25 times 25, I think is 625, right? So we have this formula. Let's go ahead and do the derivative implicitly, and when we do that, we get 2x dx dt plus 2h dh dt equals 0. A lot of people would put 625 there. Please put 0 because the derivative of that constant is 0. At this point, we just want to plug our values in, and we are solving for dh dt, remember. We're solving for this guy. So I need to put values in for x, doggone it, for x, for dx dt, and for h. Now I have x is 17, and I have dH dt is 2. I don't have a value for h, but I can get it. I can use the Pythagorean theorem. Because I know that x squared, which would be 17 squared, plus h squared equals 25 squared, if I simply do 25 squared minus 17 squared and take the square root, I will get a value for h. And I'm going to do that on my calculator and let you know that that value is, it's the square root of 336, which is approximately, what is it here? 18.3 feet. So for this h, we'll put 18.3 in. And now our job is simply to solve for dH dt. So I'm going to have, what is this, 34 times 2, 68, plus 36.6 dH dt equals 0. That means dH dt is going to be negative 68 divided by 36.6. And it makes sense that that rate is negative because this thing is dropping, right? This thing is moving down, and so that height is shrinking. And let's crank out this negative 68 divided by 36.6, and we'll hope that that answer is one of our letters on our answer choices. And that turns out to be approximately negative 1.86. That is feet per second. And if I check my answer choices, I see negative 1.855 is letter W. And so that is the letter that I'm going to choose in terms of solving the puzzle. So we've drawn a picture, labeled the things that are changing, organized our information, written an equation, taken the derivative implicitly, plugged in the numbers correctly this time, and then solved for the missing rate. And then, of course, on this problem, once you solve for the missing rate, you do have to go and choose the correct letter so you can solve the puzzle. Okay, second time's the charm, hopefully. And if you need me for anything, please let me know. I'll talk to you soon.